Alright, it's time to have some fun now. We're going to look at moles and molecules and Avogadro's number. Alright, so 1 mole is a quantity that contains 6.02 times 10 to the 23rd items. So we're talking about chemicals. So we're going to talk about moles of atoms. And if I have a mole of carbon atoms, I'm going to have 6.02 times 10 to the 23rd carbon atoms. If I have 1 mole of water molecules, I'm going to have 6.02 times 10 to the 23rd water molecules. If I have a mole of vitamin C molecules, I'll have 6.02 times 10 to the 23rd vitamin C molecules. This number, this huge big number, 6.02 times 10 to the 23rd, is called Avogadro's number. Now, that is not avocado. It is not a green vegetable or fruit, I guess. It is Avogadro, named after a great mathematician who did a lot of work with gases. And so he came up with this number, and it's really a cool number because it allows us to go from the tiny, tiny microscopic world of atoms to our world of grams. Okay, so we can use Avogadro's number as a conversion factor to relate how many moles of something we have to the number of atoms or molecules. So 1 mole, we said, is the same as 6.02 times 10 to the 23rd atoms. Remember, if it's a conversion factor, we can flip it upside down and it still means the same thing. And you can use it for atoms or molecules, either one, okay? So 6.02 times 10 to the 23rd is the bridge to go from atoms to moles or moles to atoms. So, for example, how many molecules are contained in 5 moles of carbon dioxide? So, first we identify what is the quantity. We have 5 moles of carbon dioxide, and it wants to know how many molecules of carbon dioxide there are. So, we know that we have a conversion that will take us from moles to molecules. And so we've got to make sure that whatever we start with, which is moles, is going to be on the bottom of our conversion. So to make sure that moles cancel, because if I put moles up here, I'd have moles squared over molecules, which would not help me. So that way my moles will cancel when I make this calculation. So 5 moles times 6.02 times 10 to the 23rd molecules per mole will give me 30 times 10 to the 23rd molecules, or 3.0 times 10 to the 24th molecules of carbon dioxide. Because I got rid of my moles and I was left with the correct unit, which was molecules. So moles and molecules are related by Avogadro's number. So if I want to go from moles, sorry, I wasn't watching what I was doing, moles to molecules, I'm going to use Avogadro, and I'm going to say there are 6.02 times 10 to the 23rd molecules or atoms, which depends on what I'm asking you for, in 1 mole. If I want to go from molecules to moles, then I got to make sure that I do the correct 1 mole over 6.02 times 10 to the 23rd molecules. And so it's a great conversion factor if I need to know how many moles there are with this many molecules, or how many molecules in this many moles.